So as kind of a sidelight to my regular machining on the 9-cylinder radial, I'm going to show you a little project that I was given by a friend of mine. What we have is a aluminum wheel right here, 15-inch aluminum wheel that needs to have this inside part machined down. There's kind of a little bit of a hump here, machined down just maybe an oh geez, a 16th, maybe an eighth of an inch all around here so that it'll fit over his hub. And so I've had to do a little bit of adaptation to get it to fit on my milling table. One of the things I had to do was I had these long half-inch, 13 thread per inch bolts, and I had to cut them off and rethread them, which I did over here on the CNC part of my lathe. And so I've got them so that they'll slide into the in and out of the key slots here. I found some washers that work pretty good to hold them in there, and these are just going to be just about right. When I put the wheel over the two bolts here, I'm going to have a plate that I'm going to drill out a hole on so that I can tighten it down to the surface. I'll bring you back and I'll show you kind of where I'm at when we're getting started to do that. Okay, here we are. Light's a little glary there. Maybe move that out of the way or just turn it off. Probably the smartest thing. Okay, you can see the two bolts sticking up here. And I'll be tightening those down with these nuts that have the half-inch 13 thread on them. And I'm going to be putting a plate in here and in here, tightening it down pretty snug, and then I'm going to find the center down in here with my laser finder. And once we find this this imaginary center in here, we're going to put the boring bar in, and we're going to attempt to get that thing so it'll run real central to this bore here. So I'll be back in a minute. Okay, one of the other projects that I've gotten involved with, I had a friend of mine who acquired these aluminum rims for his pickup from a fella, and found out they didn't quite fit over the hub. There was about I don't know, roughly probably about an eighth of an inch difference between fitting and being too tight. So as you look down in here, there's kind of a little rounded area in here, and that rounded area seems to be the difference between fitting and not fitting. So I told him I'd go ahead and try to machine that area for him. First problem we encountered was how do we tighten this down to the table, and I had to come up with a couple of extra long bolts, and I had to cut the threads on the bolts because the threads didn't fit my half-inch by 13 threads per inch nuts that went over that. Interesting story about this particular bolt right here. There's no railroad bolt we found laying along the side of the tracks about an inch diameter. It had been rusted and twisted, and so we machined it down so that it would fit this thread, and we were able to, in the end of the bolt, we made it so that it would fit the key slot. So it turned out okay. First thing we have to do here is to find the invisible center of this hub so that we can center our tool appropriately and do the machining. What we plan to do is do the machining in one pass. So we've already got the tool set to the proper dimension, which is 2.865 inches in here. And we're going to show you how we go about that. I got my laser. Yeah, this R8 collar is fighting me. I got my laser center and edge finder here. And works pretty good for finding this. Of course, we use the DROs. DROs really help us a lot on something like this. I like using the overhead DRO instead of the one that's on my RX30. I think it gives me a little bit more accurate reading. Tighten this down just barely. We don't have to tighten it much on this aluminum. The aluminum housing for my center finder here. So I'm going to turn the light off and see what that does to our overall lighting here. So I can see the laser dot. The laser dot's always a little problematic to turn on this thing. It's supposed to push it in and move it over. There we go. Okay. So I'll turn on the Genix. I'll get everything else fired up on the computer and CNC. And that's set to mill. This is my Patriot CNC, of course. Bring up Mach 3. And we'll find our edge here, and then we'll zero out our y-axis here first. See how fast our machine is moving. Reset. It's moving pretty fast. Okay. Which is good for now. We got a rough surface. It's really difficult to find the center. Set the Y, and we'll chase it over to the other side, and we'll see where it stops. Sorry for the head. I have to try and see where that dot's going to stop here. Looks like 2.757. We'll put it at 1.38 as a halfway mark. find our x-axis here. We'll zero the x. Run that over. Okay. According to that, that's halfway. Alright. So we're just going to leave it right there for now. And we'll remove the laser center finder, put our boring bar in there. Turn the light back on. Well, that's not exactly what I wanted to do, but it'll work. Okay, so this is the boring bar that I made myself. As you can see, it's got a high-speed tool in there. I've got it machined down so it fits a 7/8 R8 collet. Does a really nice job. Oh, maybe you can do it. So the first thing we're going to do is going to bring this cutter down very slowly and make sure that we are centered the way we want to be. There. That's looking pretty good. Sure that we are centered. I don't think I can get any closer. And just like that, we have a beautifully machined surface. Yeah, that's beautiful. And it's about perfectly centered too. Okay. So, that should do it for now. Okay, just to give you a little bit better shot of the machine surface inside here. Appears to be very evenly distributed all the way around. The center finders really make doing these kind of jobs kind of a dream. Let's see a little bit better there what's going on.